We continue with the second subtopic in chapter 7.0, subtopic 7.2, chemical properties of haloalkanes. At the end of this subtopic, students should be able to explain nucleophilic substitution reaction of haloalkanes. Haloalkanes have two types of chemical reaction, which are nucleophilic substitution reaction and elimination reaction. Now we will discuss about nucleophilic substitution reaction of haloalkanes. Halogen have electronegativities significantly greater than carbon atom. Consequently, the CX bond is polarized. CX bond is a polar bond. Nucleophilic substitution reaction involves substituting the halogen atom in haloalkanes with a nucleophile. Some examples of nucleophile are water, ammonia, hydroxide ion OH-, and cyanide ion Cn-. It is a general compound of haloalkanes. Nucleophile will attack carbon-bearing halogen atoms X. Bond between carbon and halogen atoms X will break, and both of the electrons from the bond will be moved toward halogen atom X. X form a stable ion, X-. Nucleophile will replace the halogen atom X. A new bond is formed between nucleophile and the carbon atom. Please refer to the general equation for the nucleophilic substitution reaction of haloalkane. There are 7 different nucleophiles involved in the nucleophilic substitution reaction of haloalkane. The first reaction is reaction of haloalkanes with aqueous solution of sodium hydroxide under reflux that will produce an alcohol. The nucleophile is OH-. When haloalkane is heated with excess ammonia in alcohol, the halogen atom is replaced by amino group NH2- to form an amine. The nucleophile is NH2-. Alcohol is formed when haloalkanes react with water. The nucleophile is OH-. When haloalkane react with alcohol, the product is ether with general formula ROR. The nucleophile from alcohol is alkoxide ion RO-. Refluxing a haloalkanes with potassium cyanide KCN or sodium cyanide NaCN in alcohol, the halogen is replaced by a cyano group Cn- and a nitrile compound is formed. The nucleophile is Cn-. Reaction with alkoxide ion RO- from a salt will produce an alcohol. When haloalkanes react with carboxylate ion RCOO- and ester ROOCr will form. I will give example of chemical reaction for specific haloalkanes compound. It is an example for the chemical reaction of haloalkanes with sodium hydroxide aqueous. The nucleophile is OH-. OH- will substitute halogen atom chlorine to form an alcohol ethanol, and the side product is NaCl. For the second example, haloalkanes react with sodium hydroxide aqueous under reflux. The nucleophile is OH-. OH- substitute halogen atom Br in the haloalkane to form an alcohol ethanol. It is an example for the chemical reaction between haloalkanes and excess ammonia. The nucleophile is amino group NH2-. NH2- substitute halogen atom Br to form an amine ethylamine. Chemical reaction of haloalkanes with KCN will produce a nitrile compound. Bromoethane react with potassium cyanide KCN in ethanol and under reflux to produce nitrile compound when the nucleophile Cn- substitute the halogen atom Br. Important in this reaction, number of carbon atom in the product is increased by 1. The other nucleophilic substitution reaction of haloalkanes react with alkoxide ion RO- from a salt. In this salt, the alkoxide ion is CH3CH3CH3 CH2O-. The alkoxide ion will substitute halogen atom Br to form an ether compound. Next example, haloalkanes react with carboxylate ion from a salt. In this salt, the carboxylate ion is CH3COO-. Carboxylate ion with 2 carbon called as ethanoic ion. The carboxylate ion substitute halogen atom iodine from haloalkane to form an ester, and the side product is Ki. Next example, haloalkanes react with water. The nucleophile from water is OH-. OH- substitute halogen atom Br to form alcohol, and the side product are H3O+ and Br-. When haloalkanes react with alcohol, it will produce ether. The nucleophile in this chemical reaction is alkoxide ion CH3CH2O-. CH3CH2O- substitute halogen atom Br from haloalkane to form an ether compound.